General overview of the structure of our project. So our project consists of a two-part distributed embedded system. The two parts are going to be here, the shears, which is commonly referred to as the rover, which we'll get into later. And that is an ESP32. 100% will be an ESP32. And then the other main component of the system is going to be the base station. And we're going to start with this as an ESP32 to reduce cost, but it could possibly be a Raspberry Pi for more compute power, or even an old laptop. So, in the grand scheme of things, the shears is going to collect the data as the sensors attached to it, but it's going to do none of the processing. So what are those sensors? First off, we are going to have the strain gauge. And this is connected directly to the ESP32 onto an onboard ADC. And this connection is likely going to be direct to the ADC, measuring the voltage that is returning through the strain gauge, and that's going to give the system a pressure reading. Now, this is going to be stored in the rover as a raw ADC value, so likely to be a 12-bit value. And then additionally, we have the Z board, which we're just going to simplify for this purpose, which is the GPS and RTK module. Now, this module has some processing on board, so at the end of the day, what will be seen by the ESP32 in this case is going to be raw timestamps, GPS coordinates, altitude, but we're only going to really take the GPS coordinates and the timestamp. And that is communicated over UART to the shears. And then next up, we have the protocol to actually communicate between the base station and the shears, which this is going to be wireless over BLE, which is Bluetooth Low Energy. Give a little Bluetooth logo right there. Horrible drawing of it. But that communication protocol has some fail-safes. It has some acknowledgements. There's a buffer on the shears which holds packets. These are each packets. Each one is going to be a timestamp, a GPS coordinate, pressure reading, and then as there's a connection to the base station, it'll offload as much as it can, wait for an acknowledgement. After a certain packet is acknowledged, then it'll delete. And that is the general rundown of how our system is going to work.